Welcome back to our Python class, and we are continuing working with SQLite in particular, and we are looking at a Chinook sample database which has a couple tables, and we have gone over the basic create, read, update, delete operations, and it would be time now to look at organizing our code maybe a little bit better. We'll look at how to create a class template for working with this database, and then we can create some nice methods, some nice properties which will make our code organization slightly easier. Again, this is just one of the approaches we can take. We can keep, of course, just using just simple functions, but let's try to put everything inside the class, sort of make a blueprint for our database access. Right, so I'll create a new file. I'll make a notebook, but maybe later on we'll move it also to a Python file. So SQLS via custom classes, custom classes, right? We'll make it an IPyNB, right? So we will import. We will create a class to connect to SQLite database and perform CRUD operations, basically, right? So we'll need to import first. We need to import SQLite, so which will do that, and that's basically it for now, right? Connecting our kernel, and we have a connection. So again, for now our SQLite database is a chinook.db here, right? But again, it's possible that it would be somewhere else, right? Again, so we created a function. So let's do this. So what would make sense? What would we put inside our class? Our class for connecting to SQLite database. Yes, indeed, right. So yeah, I'll call it Chinook database. Okay, why not? So right on class Chinook. Right. So class definition. So we'll make a, of course, init function, right? Constructor, something like this. Let's take a look. Let's see what yeah, destructor also would be good, right? And let's see about tables. We'll talk about that a little later. Let's see if do we need everything? Maybe not. Let's see. Again, I'll maybe move it back a little, one tab. So constructor, self, and a pass. We connect, we have pass, we save the pass, we have a connection, and also we have a cursor, right? So we create a cursor. Again, this is just mostly for convenience, because if you have a connection, we can always get a cursor, but it's nice. So we have connection, cursor, and the pass. And then a destructor. Again, typically a good idea. Working with database, it is a good idea to, again, if we are working or program, it will be called when object is deleted. So typically when program ends, right? So it would not be a big huge disaster if you didn't have this destructor, but it is a good idea, right? Again, remember init, that's construction, right? It's called when of this class, right? And this is destructor when we do it. Okay, we'll talk about this maybe a little bit later. We'll talk a table, but let's see how it works, right? So on we have a connection, right? On class, and of course this is, I'm gonna, this template is saved now. Again, would be later on we will move it. Later on we can move this class to separate file, import it, right? That would be a good idea to do. Allow it to do something on our to-do list, right? But now, so we have constructor, and I also have a connection closer. So how would we use it? So I'll basically have new. Basically, my db or db equals, yes, and that's it, right? And of course, we have access, right? We can say, db, we can do status, we have connection. You see, notice how we'll have connection, cursor, and db pass, right? So we'll say we'll do db pass, and it will print the address, right? And we can now do queries, right? We can now, of course, now we can run queries. Yeah, self cursor, right? db cursor, in this case db cursor, right? db cursor execute query method, right? Among other things, right? So it's a way of organizing your code, basically, right? Nothing too difficult, I don't think, but could be helpful for more complex projects right, to how to organize this, right? You have a blueprint, and also it would be nice, right? This is useful also, especially useful if you have multiple databases. Yeah, right, right, because you can of course if you have multiple Chinook type database with a similar schema, right, this will be quite I mean, this will be exactly the same steps, right, no matter what kind of database you use, right? But let's make some CRUD operations, like we would like to get a list of all artists, for example, right? We have our Chinook. Let's take a look what kind of query we could make. Maybe we could make something more difficult. Maybe let's do all customers. Right, we would like to get all customers, right? Maybe again we could get started with some customers, but invoices also we could do invoices, I guess, right? Which have more columns here, right? And we would need to know what invoices are there, customer data, or artists. Again, we get all artists, right? And let's do that. Maybe let's get all artists. Define get a list of all artists, right? Yeah, read artist self, right? Notice self, right? Right, and this is fetch all. So this will be what? List of tuples, right? So this is how you could do it, right? Define, say, read artists, and it actually runs the query, right? And we will, of course, this would work. Return self cursor fetch all. Again, this is a class-based approach, so we're gonna define. Of course, I need to run it since you know, each time I add a new method to our class definition, to our blueprint, I need to, of course, save it here. Of course, otherwise I'll have to import it from if it is another file. But okay, so now connection. Well, question is now: do I need to? Well, actually, I'll need to reinstantiate the database connection as well. But I should be able to get my artist list. Artist list equals what? DB read artists, right? And of course, length of artist list will be, I have probably, I'll get like, let's list some first 3 artists again. So artist list first 3, right? And it should work. Yeah, ACDC, accept, and Aerosmith, right? So it works quite nicely, right? Again, of course, now simple queries, we could of course make it more, you know, have extra classes, right? We could have a list of classes, for example. We could store or some data internally, for example, right? Some extra data. Maybe you would, each time you read artists, maybe you would cache a list of artists. So saved in memory, right? You can have some extra things. So read, right? You could add data, right? We could add update, for example, add a new art, you know, create artist, you know, they have a create artist. Yeah, right. Insert, and again notice parameterized query, right? Again, for safety, for security reasons. Again, right? Things we did before. Same again, commit is after you have insertion. Remember, you have to commit. Of course, now I could also return self. Return self. Return self. We could. Well, yeah, we could do that. We could just keep adding. We could return self, yourself to make this to allow chaining. So return self, right? So we can add more artists, right? And keep just adding them, right? That'd be one way of doing it, of course, right? And also, of course, we could also, right? This is pretty nice, but let's also insert a list of artists. So what will we do? Self artists, right? On execute many, insert a name, values, artists. That's very interesting. Will this work? Execute many artists. That looks execute many. Insert, maybe actually it will work. Actually, it might work. Actually, right? Sequence of parameters. Yeah. So this actually might be quite nice, right? So we have 2 creation methods. So let's take a look, right? So let's save it, right? And we can do, again, I'll make a connection. I'll have a list of artists. Let's get me last list of artists. Last three, right? Yeah, remember our drop table experiments, right? we were not able to, due to our security precautions, we were able to have our parameterized queries, and we couldn't destroy this table, which is good, of course. Right. So let's then start a single artist. Artist of the day, I don't know. Probably not Kanye West, probably, right? But probably, I don't know, Lady Gaga we already did. I don't know, Nicki Minaj, I don't know, right? So we'll do, so we will add, not, or maybe, well, Elvis Presley, we'll do Elvis, but probably Elvis is already there, probably, right? Some of the newer ones, I don't know. Well, okay, I guess somebody who is a good, I think there's no David Bowie, so let's add it to create a new artist. So yeah, my new artist, but of course it won't be, it'll be David Bowie. Let's say David Bowie, right? And it should be inserted, right? And of course we have quotes, right? Come on. And we need, of course, this is case, since these are strings we're inserting, of course the actual insertion matters. Okay, so autocomplete is sometimes, yeah. Okay, so now of course if I get my artist list and I will, double check, right? I'll get again, I could basically, read again. So I hope you see appreciate how easy it's not once you do the work ahead of time, right? It makes it easy. Well, in effect, of course, you're making your own object or own ORM, right? Object relational mapping, actually, right? But I think it's not that hard, right? So artist list, last three artists, last three, right? One, right? Yeah, we can see David Bowie has been added. Okay, so let's test adding multiple artists. Multiple artists, my artists. Let's see what artists. David Bowie, Queen, Beatles. Well, they are. I think all of them are there already. I would like to add some more. Only thing is now multiple artists is this single. We need to have a list of tuples with single element tuples, right? So a list of single element tuples. Indeed, a list of single element tuples, and this will be added. But again, so there's not going to be any check for multiple David Bowies. Let's see. So, and of course, I'm going to do this again. So, my artists, DB, create artists, right? And of course, my artists, and then get last three. Right, and of course, last three, and I'll do that. Let's see what happens. Actually, well, let's do last 5, right? Actually, of course, now if I do it over, right, I'll do last 10, right? Looks like 2 Jumprovas, right? We have a couple drop table experiments. You have 2 David Bowies, Queen and Beatles probably already there. There's my name as well, right? All these artists have been added, right? So yeah, so this looks like nice thing we learn is this execute many, right? So this is if you have multiple insertions, right? You could, of course, alternative would be for art. Yeah, that's what I was gonna do, right? I would have do this. That's what I would do, right? That would be alternative, right? For artists, again, speed-wise, it should be very similar because, well, maybe this might be slightly faster, but not too much. Again, it should be similar speed. Should be similar speed, right? I would say similar speed again, but need, as long as we do not yeah, I have too many artists, yeah. So self-con commit, right? And again, also note how we only commit once, right? So that's something might be to keep in mind, right? Some alternative. So this is, yeah, I think again, if you don't know this execute many, if you didn't know about this, right, you could use this. This is a standard, just execute, do one. Again, the name executes maybe slightly negative connotation, but it's a good thing in this case, right? So, right, so we learned to add. How about update? Let's do an update, right? So create, read, create. Let's do an update. Def update artist name, right? Self ID, right? On yeah, new name, safety, again parameterized query for security reasons, right? On commit. Nice. So again, self ID, new name, right? You just need to know, as long as you know the ID, right? Well, of course, the question is now, by name, right? Artist, I would say by ID, right? How about make one more? Update artist by name. Update artist's name by name, right? Old name, new name, right? So notice this is, of course, again, right? Also, this could change multiple rows, right? So that's something to keep in mind, right? This is obviously ID. ID will do one single, right? Update artist by ID, update artist by name, and of course it will change, right? Set name, where name, the new name, old name, commit, and return self. Right, pretty nice, I think, nice way of organizing your database interactions. Of course, again, it will keep growing. If you want to do, you can have maybe 50 different queries, right? At some point, it could get maybe too big. Maybe you'll have to do some sub classes, maybe some other way of doing it, right? But it's definitely much better than just keeping everything in single functions. It'll be a much bigger mess. At least now you have everything in one place. And again, nicely, because if you have this database, well, then you have this method again. The connection self is actually, right, this it knows I have a connection, I have a cursor, right? It knows exactly what to do, right? So no less chance of making mistake by picking the wrong cursor, right? Again, hunting for a bug if you pick the wrong database cursor, for example, right? So if you have multiple databases, if you have a single database, of course, this might not give you that much of an advantage. Well, let's take a look. So we have time. Well, we're doing very good. Very well, actually. I think update artist by name, and let's test this. Again, I'll have to make a connection. Of course, I need to again, I'll run it, I'll make a connection. Of course, my databases, right? I want to create I'll guess we'll change David Bowie, the Queen. Maybe I'll do the Queen, right? But Queen actually was not Zeb Queen or Queen. Actually, it is Queen. Actually, right? It is actually Queen. So that wouldn't be. Let me see. Well, what's David Bowie's name? Actually, let's see. I think David Robert Jones, I guess, right? The Beatles, right? So let's change Lady Gaga to actual Lady Gaga, right? So 280, we'll change to 80. So let's try this, right? Of course, right now I don't have a artist list. Get artist list equals yeah. All right. So we want 280. Let's change it. Let's change the 280 to Lady Gaga. Yeah. So indeed, that should do it, right? And now, if I again, I'm not even gonna update. I'm just gonna do it quickly, right? I'll just basically, of course, minus 10 directly, right? Since I'm lazy. Again, of course, on large, right? So of course, right? So last 10. On what did I do? Mistake? ID. There was no ID. I write. It is, you know what? We didn't change it. It's actually where ID, but let's look our schema. It's artist ID. Artist ID. All right. And again, the case doesn't matter, right? But or schema, right? But it's just for name. So let me do this again. Let's connect. Let's change it. No, let's do it one more time. Yeah, and Lady Gaga is indeed correct now, right? So we change it. Now again, so maybe we need to get let's do tail. Let's implement a tail function. Let's do a tail function with a number of artists. Actually, good question. How could we do this? Can we make a tail, our own tail function, which would just get the last artists? Right. We could by tail separate the sending. Let's see, SQL. Let's make a tail function. Tail, no, not recursion. Tail, let's get tail of artists table. How do we do it? Right, artist table, and then, right, from order by descending limit right, and limit is entered like this. Again, so again, just in case somebody is not controlling this number, right, this will give me the last 10, you know, by default 10, you know, as many as you want, but we are sorting in descending limit, right? So then of course you would want to maybe reorder it. That's again up to you. We can do it also. I think we can do reorder again then, right? Yeah, we could do it also, then reorder again. We could do a subquery if you want, but again, it's up to you how much you want to, you know, have extra functionality. It's up to you, basically, right? So let me make a connection. Let's make a tail, right? Well, not like here. Oh, here we go. Escape B. Let's get tail. Let's get tail. Right, and of course 10 was not necessary, so I could do 5, right? So to 80, I'll do, let's say, 12, right? Default is 10, right? Default is 10, right? And of course, right? So this will be fast, right? You see already we start here, getting here, right? Of course, I could do reversed, right? And so on, and so on, and so on, right? So this works already pretty well. Okay. Now, so we'll implement. We have update. Inscrate. Let's do delete, right? Let's implement delete. So delete artist by D. Define delete artist by ID, right? And we could do it, right? Right, again using the ID connection commit, right? And this would be the ID, and let's do by name. Yes, thank you. AI is so smart. It knows, it starts learning the patterns. Again, pattern recognition. Well, it picks up on the patterns, right? And will create the appropriately named function. Again, makes your life so much easier. Again, but so delete from artist where name equals. Again, notice again you have, of course, again parameterized queries, right, and again. Yeah, on commit return self. So now we can again notice how what can't we chain? We can't chain. Only thing we can chain is we can't read artists on tail, right? Tail also is not readable, not chainable, right? Because you will actually getting a Python object, right? You're getting list of items. Otherwise, you're getting the same database connection. So you can change, right? You can add artists, right, and get tail. For example, now. I think we have pretty nicely set up we set up for basic operations through artist. I hope this was not, well actually I create this as yours for you have exactly artist, so your homework will be very easy, right? But it will be maybe you should maybe do an album, maybe, right? So since this is exactly what you would want to do at your homework, right? So this is mostly going through the homework. Now let me make a connection. Right. Yeah, Chinook, right? And let's get a table, right? Let's get a table. Let's get a table. Let's get tail of 5, right? Yeah, the bill. Okay. So now let's add some new artists. What are new and upcoming artists? I don't know. Let's see. All right, so let's add some. Let's change some queries. So yes, David Queen, Beatles, and so on. Okay, of course, this is exactly how you could do it, right? Can we actually do it like this? No, unfortunately not. So we have to do this. Unfortunately, right? Yeah, you can do this, right? Yeah. If you want to chain it and make it nice, right? So you need to add this extra symbol, right? So if you want to make it, right? So obviously you could just basically then do, right? No, I'm using, yeah, for line breaks, for line. New line. Yeah, okay, so yeah, notice there's no space, right? So this is possible to do it like this, right? And of course, let's do some other names. So let's say Ansis, I don't know, Lauris Reinix, I don't know. I'm sure they know him in Lithuania. Who else could we add? Somebody from new. well, Beatles will some other Tina, but of course, all right, she's not really new, but okay, why not? All right, right on. Now let's take a look. Let's read 8. So this should be quite readable, right? Right. So we have a nice little addition, and we can read. And of course, also we could have a function to return data frame of all artists. Let's do that, right? So what do we need? We'll need also, of course, import pandas as PD, right? Since we're doing good time here, almost, yeah. Let's add a function, return data frame of all artists. Return data frame with all artists, right? And it does again, basically, right? All right. So now this is nice. Again, the question you might be asking, okay, so why would you want to again do this? Because you could do this. I mean, you only have one extra line, but of course, this is, well, again, you sort of abstract, so you create an abstraction. Again, you have a documentation by abstracting this operation, right? By abstracting, we can change the information later, right? Also we create documentation for this method, right? Automatically, right? We have again, only requirement was that the data frame was, let me import again. We had on, hopefully. All right. So now I should have made something for albums, but artist is easiest, right? So I will maybe later on we'll do it with something more complex, right? And now we can of course have a connection, right? So and I can of course now go back right here, and I can get the data frame, right? Artist df or artists df equals what? db artist, and of course df head, and we could do artist df. Now we could do, of course, right? And now of course we could do artists df tail, right? And we could start working, right? Now we could start working. Now we could start working on the data frame, right? Without worrying about database, right? That's also possible, right? Again, so we have nicely gone through and added put everything, so encapsulate everything in a single class definition. And again, well, as long as the database has an artist table, well, with these particular schema, right? Well, it will work with multiple databases. Of course, again, it really depends on a project, but I think it's definitely a good, I would say, probably preferable alternative to just having a bunch of functions on, and trying to hope everything you can remember which function does what, right? So nicely organized. You have a template, you create an object, you create a single database object, right? So we create a single data object of this class, right? Then we can start operate, right? Opening connection, right? We have maybe let's add one more thing. Let's add a created connection, created print status. Yeah, something like this, right? Let's do that one more time, and then we can ready to work, right? And maybe I'll do F. I'll do this. Oh no! Let's do that. let's not do that. And ready to work. Okay. All right. That's not. Okay. Yeah. I'll do one more time. Alright, and now we can do whatever we want again with these methods. So just add more methods. Just add more methods for other tables, joins, views, etc. etc. Right, and we will actually probably do that in a class. We'll do more. So to do explore, do explore group by having, or by, well, group by and having, right. Okay, that's our next step as the SQL features. All right, thank you everyone. Hope this gave you some ideas how you can organize your code using object-oriented programming principles. Again, putting your blueprint for your database connection, creating a creation of when you create your constructor creates connection, right? And you have a lot of methods to work with the database. Basically, return some data, update some data. I think it's pretty you know, I think it's pretty reasonably easy. So in fact, we have made our own right ORM. So ORM, yeah. So ORM on wiki, yeah. Something to read also for future use if you want to read more about this. All right, thank you, and see you in the class.